back a little bit. Okay, all right. So wonderful to be here. It's fantastic to share with clinicians, policymakers, and technologists. You know, that's always important. And if anything, with the speed at which things are moving now, it's become even more important. I'm going to speak briefly about Google, about the Alphabet Group, what we're doing in healthcare, and specifically what we're doing with AI. So let's get into it. So first of all, on Google and the Alphabet Group, we really touch healthcare in many parts. As you know, we're both a consumer business and an enterprise business. And if I give you a few examples, obviously a lot of health consumers access healthcare data through search. It's often where billions of consumers start. A lot of consumers consume information on healthcare through YouTube. We also own Fitbit, which is Fitbit Health, which is obviously a wearable used for healthcare monitoring. The cloud technology, let me see if I can use this up here, cloud and AI technology, that's where I sit, and we provide that to healthcare organizations around the world. And then we have organizations like Google DeepMind, and I'll touch on what they do, but which are really trying to advance research and bringing the best of computing and AI to scientific research, okay? And then we have companies like Verily, and Verily is very much in the life science area, and Verily is working on the automation of clinical trials, improving clinical trials, improving clinical research. Okay, so we touch healthcare in a lot of ways, and the way we bring that together is to Google Health, okay? And Google Health is an initiative, but it's a permanent initiative. So Google Health has a permanent workforce. It's led by our Chief Health Officer, Dr. Karen DeSalvo. And Google Health's mandate is not a commercial one. Google Health's mandate is to actually improve the health of people across the planet, okay? So that's how and Google Health partners with healthcare organizations, leading healthcare organizations and leading research organizations, and brings the assets from across the Alphabet Group to bear in doing so. Okay, so here are some of the areas where we have focused as a company in terms of healthcare. So a lot in the area of radiology, specifically around lung cancer, so very much detection and screening of lung cancer, breast cancer, also tuberculosis, okay? Secondly, ophthalmology, so how we can use, diabetic retinopathy, glaucoma, both for screening and detection. Third area would be in areas of digital pathology, again for cancers and metastasis and tracking metastasis from tissues, and how we can apply AI to that, okay? And then also on the ophthalmology, interestingly, how we can use AI on images of the retina to detect other conditions, for example, early onset of chronic kidney disease. So these are specific areas and examples of areas where we, as Google, have decided to focus. And again, we do this in partnership with leading health research and health provision organizations. Good. So generative AI, just a little.
You as a user can put in what you have in your refrigerator, and whether you want Mexican food, Chinese food, or different genres of food, it'll create a new recipe for you that's custom to the food that you have. On Monday, we thought maybe this is possible, but by Friday, with Google Cloud, it was real.
Desculpe lá, mas eu quis apresentar.
With Google Cloud, we at Bayer use generative AI to create synthetic data that generate new specific models for solving diagnostic problems. Faster diagnostics and better treatment can make a real difference in people's lives.
Priceline is building a new way to search, price, book, and experience travel at scale. It's taking generative AI and it's connecting the dots for a consumer, much as you would call up a travel agent.
We are a geographically diverse company with many non-native English speakers. Duet AI has made writing so much easier for everyone in the company. We're all able to speak the same language.
So, I guess the way we think about generative AI, and AI has been around for a long time, but specifically on generative AI, is that in the same way that computing, essentially has created a new industrial revolution, it's changed industry, but it's also changed how we live. Generative AI is going to fundamentally change computing, and it's going to change the interface between the computer and the human. Okay, and in doing so, we think it will herald and introduce another industrial revolution, because fundamentally, computing and the human will work more closely together. So and I saw the previous speaker had referred to McKinsey and McKinsey's Global Institute. This is the view of different industries in terms of how, to what extent generative AI will impact those industries in two ways. On one axis, productivity, so to what extent will it impact productivity? And on the other axis, how will it impact the products of the industry? In healthcare, medications and healthcare services. So you can see actually, after media and entertainment and the software industry itself, healthcare is the next highest. We expect that healthcare will be radically impacted by generative AI. And I think those of us who have worked in or around healthcare should not be surprised by that, because everything in healthcare has to be data-driven, right? From diagnosis to treatment to the development of medicines, everything has to be data-driven. But at the same time, we have had a huge issue in harnessing our data, making use of that data, bringing that data to the clinician in the right format at the right time, having a longitudinal record. So a technology that allows us to do that better will, of course, we expect it to have a significant impact on healthcare. So a little bit on what we're doing. So this is MedLM. I'm not going to start doing a tutorial on generative AI, but essentially, large language models are key to generative AI. MedLM is the first set of models that were built specifically on clinical data, okay, and that were tuned using parameters developed by clinicians. So an example of that is using parameters such as the degree of medical consensus. Okay, so prioritizing outcomes that score higher in terms of degree of scientific and medical consensus. Another one is harm, the risk of harm. So how do you tune the model to ensure you're prioritizing outputs that have a low risk of harm? Bias is another one. How do you actually ensure that the outputs of the model are less likely to have bias, whether it's ethnicity bias or gender bias, etc. Okay? So this is MedLM, and this is being used today, and I'll go through some examples. The next generation after this is called MedGemini, and we've already published some material on MedGemini. This group of models will be multimodal. They will be tuned for healthcare, but they'll be multimodal, and that's very, very important, because we all know in healthcare we have numerous different data types, from text-based data to genomic data to image data to video data. So think about all the things that clinician needs to essentially use when they're looking at that longitudinal patient record. So MedGemini, which is currently in private preview and will soon be generally available, will actually be able to reason across genomic, image, video, and text data, okay? And an early stat is on that MedQA exam in the US, MedGemini scoring was about 91.1%, okay? So just to give you an early benchmark there. Another innovation from Google DeepMind, and some in the audience in the research side might be aware of AlphaFold. AlphaFold is an algorithm that was first introduced in 2021. And it's to actually predict protein structures, okay? AlphaFold has now been cited in over 20,000 research papers, peer-reviewed research papers. AlphaFold 3 was just launched. AlphaFold 3 goes beyond protein structures down to the DNA, the RNA, the antibodies. And it doesn't only predict the structure, but it actually predicts how these can bond, so how these will interact. And this has been set up in such a way that the researchers have access to this. This is not a commercial offering. This is free to use, and they can interrogate this, and they can enter hypotheses and then actually test these. So this is a great example. We all know that generative AI is a double-edged sword. There's risk and there's benefit. But I think AlphaFold is a great example of actually how generative AI can really drive cutting-edge research right across the biotechnological domain. Okay, and then I won't go through all of these. These are some of the examples, but I'll run through very quickly some of the areas, some of the real examples we have today. So Highmark is using generative AI in a patient app. This is a personalized patient app. So it brings together both information on what the patient is eligible to in terms of services, information on how to access those services. It also takes their patient record and suggests actions in terms of preventative health. Okay, so this is, and most of these examples, frankly, are going to be US purely because the models, as of yet, have only gone into production, if you like, and gone through the compliance in the US, but we now have roadmap for those to come to Europe. Second example, this is actually for the care pathway. So this is where we're using MedLM to provide the summaries, specifically for the handoffs between doctors and nurses. As a nurse or doctor moves off shift and a new shift comes in, these will create the summaries to streamline the handovers and ensure that all relevant data is picked up. So this is being used by HCA, which is the largest public healthcare entity in the US. This one is with Mayo Clinic. I think you're probably familiar with Mayo. This is actually in the delivery of radiation therapy. So as you know, every time we deliver radiation therapy, we have to do the segmentation. We have to delineate the healthy tissue from the tumor. This is a time-consuming exercise. So Mayo are now using AI to do that. It moves from several hours to a matter of seconds. But not only that, because it gets a lot faster, we can afford to do it during the term of treatment, which means, of course, we can read as the physiology changes and the tumor reduces, we can resegment and therefore redirect. So a great example there. Meditech is an electronic medical record provider, and I know Portugal has its own electronic medical record. We've tended to look at electronic medical records somewhat as legacy. But what's very nice with Meditech is they're actually providing new services by integrating AI into their electronic medical record. Two things they're doing is that AI for summarization of the clinical note. Okay, so helping the doctor prepare the clinical note and also on the progress summaries, also discharge summaries. The other thing we're doing is, Meditech is looking at AI for clinical decision support. So as new data comes in real time into the medical record, it's not possible for the doctor to check the medical record each time lab results come back, each time there's an X-ray, each time the nurse checks the biomarkers. So we're using the AI to do that, to check the effects of the real-time updates to the medical record and then prompt the doctor on potential actions that they need to take. This is Augmetics. This is for virtual scribe, which basically means we're using a MedLM to listen to the clinician-patient conversation, okay? So the clinician stops looking at the screen, stops entering notes. That's all recorded. And then we structure that and we create the draft clinical note. So at the end of the consultation, the clinician can just look at that draft clinical note, make sure everything is complete, and then submit to the electronic medical record. The whole idea here is, of course, to give time back to care. Take away the bureaucracy, let the clinician focus on what they're meant to focus on, which is listening to the patient and diagnosing and preparing treatment plan. Okay, very close to the end here. This is just how we're starting to think, and I think the previous speaker mentioned this, not just thinking about point solutions and technology, but how one might change the entire pathway, okay? And this one is specifically around triage. We know that triage, we get overloaded in emergency departments, etc. So what we're thinking about is, with the technology, how can we avoid that? And how can we actually empower the patient to actually self-refer and self-navigate? And then when they do come to the triage point, we ensure that on one side, the patient comes with a full set of data, okay, and the clinician is empowered, to focus on the data and focus on the patient and not on the bureaucratic elements around it, right? So really, remove those pinch points, give more reassurance to the patient. And one thing I'd like to challenge this group on is, when we have those moments in our healthcare system, when we invest in new hospitals, right, new services, these are moments when we should really think radically about how we should do the entire process differently, right? Because once we build, that building a certain way, then in a way we've locked in an old way of doing things, frankly. Okay, this is some work we've done in Portugal. So it's an example of that intelligent agent.
Olá, o meu nome é Maria e sou assistente de atividade clínica da NOC. Estou aqui para ajudar a preparar a sua consulta com o médico. Concorda em que lhe pergunto o que sente para passar essa informação ao seu médico?
Sim, concordo.
Muito bem. Então, por que motivo procurou esta consulta médica?
Dói-me a cabeça e tenho um pouco de febre.
Entendo. E há quanto tempo tem esses sintomas?
Desde ontem.
Muito bem. E tem mais algum sintoma que pretenda que eu passe ao médico?
Tenho-me sentido um pouco cansada.
Muito bem. Vou reunir toda esta informação e passar ao seu médico. Desejo-lhe rápidas melhoras.
Já agora, já partilhei as minhas análises. Pode-me dizer se está tudo bem?
Não posso fazer essa avaliação, pois não sou médica. Mas vou passar as suas informações ao seu médico e ele poderá avaliar as suas análises e dar-lhe um diagnóstico.
Obrigada.
Olá, Sofia.
Olá, doutor.
Já sei que temos aqui alguns sintomas desde ontem, como a dor de cabeça e a febre, e também algum ligeiro cansaço.
É verdade.
E também detectámos aqui uma tensão baixa nos exames que também partilhou.
So this is some work my colleague Luis did with NOC, who provide teleconsultations. NOC are already providing the teleconsultation, but the idea here is to put that intelligent AI agent in front of the teleconsultation so that essentially it gathers information, okay? And then, therefore, when you move to the consultation with the clinician has, wastes less time and has more information and can have a more pointed consultation, therefore driving productivity and a more quality conversation. So just a small example. Just to finish then, I think we have a nice stand outside, and we're partnering with Go Life and Real Life, and there's some really nice demos with our MedLM capability at the stand. So hopefully you might take a few minutes and come and look at some real life demos on clinical decision support from Real Life using our technology. I'll leave it there. Thank you very much.